Good morning, good afternoon, good evening, everyone. I have the pleasure of welcoming you to today's webinar on advocating organic farming for sustainable nitrogen management in Africa. This webinar is organized by the Global Partnership on Nutrients Management as part of a series of information sharing technical webinar. And today's webinar aims to showcase organic farming strategies and their potential to promote sustainable nitrogen management in Africa. My name is Liu Ning. I'm your moderator for today's webinar, and I work in the South to Sea Pollution Unit at UNEP in Nairobi. Without further ado, it is my great pleasure that I introduce you Dr. Tom Bruce Lemma, Chief Scientist at Plant Nutrition Canada and a member of the Global Partnership on Nutrients Management Steering Committee. I welcome him to officially open this webinar. Tom, please.
Thank you, Liu Ning, for that introduction. Are you able to see my slide?
Yes, please.
Thank you. Okay. Well, I'm honored and slightly puzzled to have been invited to give the opening remarks for this webinar. I am I'm a person who works with the fertilizer industry, both in Canada, the United States, and internationally as well. And as such, I've had a role on the Global Partnership for Nutrient Management. So I'm speaking really on behalf of the steering committee of the Global Partnership, which is a platform for governments, United Nations agencies, scientists, and the private sector to forge a common agenda. We have produced in the past documents like the one I show here on the left, which is a position paper on nitrogen use efficiency and nutrient performance indicators. And that work has led to a lot of consensus building on the use of indicators like nitrogen use efficiency. And I will, in my next slide, show a little bit about how this relates to the African context. We're working together with all of these stakeholders to improve nutrient management and reduce excess nutrients in the global environment, consistent with the needs of global development. So sustainable nitrogen management is a large component of that. I've had experience in dealing with previous organic farming workshops, and where that started back actually in the year 2002. I was invited to give a talk at a workshop on organic farming organized by the OECD in Washington, D.C. Around that time, both Canada and the United States were establishing national standards for organic food, and they're able to tally with statistics how much that comprises in the agri-food economy. And in the two countries, in Canada and the US, we're now at about 3.3% to 5.5% of total food sales for the two countries. Keep in mind, of course, that organic foods are sold at a premium, so the actual amount of food supply is smaller than these figures would indicate. And keep in mind as well that this is a small component of the agri-food sector in North America. I'd also point out that within the fertilizer industry, we are agnostic as to we serve all farmers, and there are over 9,000 approved substances that include nitrates, chlorides, and sulfates produced by members of the fertilizer industry. The African context, we have many countries that have low nutrient use and low crop yields. Soil nutrient depletion is a large concern. And so we need to keep in mind these figures come from the FAO, the crop nutrient balances of Africa. The input levels and the output levels of nitrogen are far lower on a per hectare basis in most African countries. But I've picked here a couple of countries just to illustrate that there is large variation among countries and likely to be large variation within countries as well. Why do these nutrient balances matter? They're important to consider in sub-Saharan Africa because soils have been depleted and even the small nutrient removals associated with low-yielding crops are not being replenished. Both inputs and outputs of nitrogen and phosphorus are much lower in many of these countries than in the rest of the world. Use efficiencies for these nutrients range from too low to too high. For farming to be productive and successful, whether mainstream or organic, larger inputs of nutrients will be needed. As in developed countries, organic inputs for organic farming come from the surplus from mainstream farms that use mineral nutrients. Thus, an important element of advocating for organic farming in sub-Saharan Africa will be to increase the productivity of mainstream farmers, which must include increasing their use of mineral fertilizers. So I look forward to hearing the presentations today, and I am eager to learn from the speakers in this conference. Thank you.
Thank you so much, Tom, for setting the scene. Now we move to the presentations, followed by a Q&A session. Panelists will make a presentation of 10 minutes, which will then leave us 15 minutes to dive into Q&A. We would like for this webinar to be as interactive as possible. So we request you to kindly put your questions in the chat box, which will later be raised during the Q&A session. We will begin the panel discussion with a presentation for agricultural development. Clemens Monia, as an environment and climate specialist at the National Fund for Agricultural Development. Clemens works at the intersection of climate adaptation, climate mitigation, and food systems. She provides technical advice to mainstream environmental sustainability and climate change resilience in IFAD's portfolios across East and Southern Africa and Near East regions. She is leading key initiatives such as IFAD's biodiversity finance tracking methodology and is part of FAO's agricultural ecosystems-based solutions expert working group. So, Clemens, the floor is yours, please.
Thank you very much, Ning, and I hope you can see my screen.
Yes.
Perfect. Thank you, Ning, and thank you, Tom, also for setting us up on the right foot. So, as mentioned, I'm Clémence. I work at IFAD, International Fund for Agriculture's Development, and I'm very grateful for the Global Partnership and UNEP for giving us a chance and an opportunity here to show a little bit about how IFAD is tackling nitrogen management for organic farming, especially in our African portfolio. So the first point I really want to highlight here is that IFAD adopts a very holistic approach, right? We're not implementing organic farming as a kind of dogma that is enforced on the partners that we work with. You can see in this diagram on the right, the array of practices that we've identified in our portfolio in Eastern and Southern Africa specifically. And you can see that it includes practices such as agroforestry, manure and compost, crop rotation, intercropping, and other practices that help with nitrogen use efficiency and nutrient management and soil fertility management as a whole. But you can see that there's also 55% here of inorganic fertilizer that is included, sometimes necessary to kind of adapt to the context within which we work. And so when I say holistic approach, I mean really looking at all of these solutions and how do we use this to improve the efficiency, making sure that we avoid any wasted nitrogen. How do we also develop the availability and the access to organic inputs on the market through research and through market approaches as well, so that we're not only focusing about the changes at the production level. And then how do we build a case for these organic agriculture practices, understanding and really being able to quantify the economic benefits for some of the partners in the countries that IFAD works with. So I'll speak a little bit more about each of those three aspects of our approach. As I mentioned, the main focus, or at least traditionally for the majority of our project, has been focusing on efficiency. So on-farm nitrogen use efficiency through recycling, through complementarities between different aspects of the farm. We're promoting legume intercropping, livestock crop integration, agroforestry as well. We have an agroforestry stocktake that will be coming out later in the year that I encourage you to look at. There's some case studies here about the use of the Phytorbia albida tree in Niger for added fertilization in rangelands, and overall soil fertility management strategies. But another aspect for us when it comes to soil fertility, nitrogen use efficiency, is making sure that any drop that is used or any gram that is used is indeed being used for production and it's not wasted post-harvest. And so we have a wide array of interventions as well that focus on reducing post-harvest losses, either through improved storage options, warehouses, food processing schemes, and so on. And then finally, where we have to use inorganic fertilizers or chemical fertilizers, we really ensure that we're focusing these recommendations on area specificity, soil specificity, specific crop requirements, etc. We're promoting microdosing, fertilizer deplacement, especially in rice systems, and anything to ensure that the nutrients that are being inputted through those chemical inputs are as per the exact need of the soil and of that crop and are not wasted. The reason we have to do this, and we still at the moment have to work through these inorganic fertilizers inputs, is because of some gaps that were identified when it comes to having access to agroecological biosolutions and having the farmers accessing sufficient benefits in the market for their organic production. So that means that where the market is not sufficiently ready, we still have to think about those temporary transitional solutions. And these two key gaps, so access on the market to the bio solution and then benefits from your organic production on the market, we've identified them as part of IFAD Agroecology Stocktake that I encourage you to look at, which we published 2 years ago. And they very much also apply to the specific organic farming transition. More specifically, when it comes to accessing biosolutions on the market, it is important for tackling lost fertility, but this is not the only benefits that we're seeing. We're seeing a lot of interest when it comes to cushioning the farmers against the rise in synthetic fertilizers, especially exacerbated in this recent context, and also in creating a lot of opportunities for the rural youth or just the rural entrepreneurial framework as a whole to create those initiatives and those businesses for bioinputs, solutions, and distribution. This requires building human capital and also engaging with the private sector. And that's kind of the spirit of the next few examples that I will be talking through. So we used to, as you can see here in Burundi, we used to provide directly some of those biofertilizers as well, and we still do in a fair bit of our portfolio. In Burundi, we'd provided specifically 360 tons of organic fertilizers directly alongside some other specified beans, etc., and then providing some training on production practices as well, market information, etc. So quite a traditional approach of promoting organic farming. But we're slowly also expanding into working for research, like we did in Malawi, where we tested the efficacy of phosphorus solubilizing organism with the National Agriculture Research Department so that they can then roll this out specifically. We had demonstration sites also focusing on rhizobia inoculation of the seeds, and then the farmers that attended some of those demonstration sites were then supported to be linked to specific markets as well, with specific tracing mechanisms and way to identify themselves as more organic producers. The initiatives in Malawi is being scaled up. We have a second phase of the project that is ongoing, and I believe some of those results are also being taken into account in Malawi's next subsidy reform or reform of their subsidy program. Where the bioinputs are not sufficiently available on the market, another way is to just reduce the reliance on the market as a whole and to focus on on-farm nutrients inputs that you can find. And so in Mali, we have a project where we've promoted biodigesters and slurry use as organic fertilizers, based on a modeling of about 4 cubic meters of a biodigester that can produce around 50 tons of bioslurry per year, which would be equivalent to around 7 hectare being fertilized. Those are, of course, kind of statistics and modeling. The project is ongoing, and we'll be looking at those results specifically to see the potential that this has in terms of increased profits and increased benefits for the farmers. Where the bioinputs are available on the market, and the issue is about connecting some of the farmers to those input providers, we have other models available. One of them we implemented in Kenya in the KSEP CRAL program, where farmers have been, through the project that we supported, have been banked with a specific voucher scheme on the card that was registered at the bank. And this voucher scheme was fed in by other bio-input providers, as well as conservation agriculture service providers who were specifically trained for the project. And the farmers that were beneficiary from the project had to give a certain amount of contribution depending on their level of economic viability. The minimum amount was 40%. Once they give this contribution, they could pick some of their input packages from this voucher scheme, and they received encouragement as well on selecting specifically the bio input packages as well. And all of them, or close to all of them, have access to conservation agriculture service providers services too. One interesting kind of finding or remark that I would make about this specific case study is the importance of taking into account the competition dynamics between some of those input schemes that might exist in some countries, where subsidizing or supporting the use and application of biofertilizers or bioinputs might come into direct competition with some of the free subsidies and free input subsidies that may be implemented in the same region. And in which case that kind of puts at a disadvantage some of the intervention that can be done for organic farming. I'll go very briefly over this one because it doesn't focus on Africa, but I wanted to show a successful model as well of a public-private producer partnership model where contract farming was implemented both from the input provider side, the farmers, as well as the off-takers later on, to ensure that the right inputs were bio inputs were provided to the farmers, and then the off-takers were sure that they were purchasing some organic produce from the farmers themselves. Through this specific model, you'll be able to read more on the slides after the webinar. There's been an increase in farmers' income from about 183% and a total of 731 jobs that were created. Now, I've said a few times through the presentation that we implement. Technically, IFAD doesn't implement the program. We give loans at preferential rates to the government, sometimes grants. And they ultimately, because it is part of their own budget cycle, they ultimately decide what input packages to be promoted with this loan and what practices to be implemented with this loan. And so a big part of our role is to be able to show the evidence as well for why and how organic practices can be more beneficial to the governments as well as to the population as a whole. A tool that we have for this is this economic and financial analysis, which we've been using for a while, but we're now working to enhance it so that it can also include some of the avoided externalities as well as some medium to long-term benefits that can be reflected in that analysis that we provide to the governments as well. This is very much work in progress, but there's some interesting findings that can be found in the literature and in some of the IFAD programs as well. In Lesotho, we had an impact assessment for a project that finished in 2020. So the impact assessment was about 1 or 2 years later. And we found that there was a substantially higher use of organic fertilizer among the horticulture producers that were benefiting from the project. And when the organic fertilizers were not purchased externally, so they came from the farm directly, either compost or manure, essentially, then the farmers knew higher profits. However, when you consider in the calculation of profits, when you give a price to this manure and to this compost based on the median price of what you can find as bioinputs on the market, you ended up finding that the profits were still negative. So essentially, beneficiaries were not considering as a cost what was produced from within their farm. And this is important to take into account when calculating the economic benefits of organic farming. We also have an ex-ante analysis of IFAD investments from the portfolio a few years back that shows soil organic carbon improvement from nitrogen use that offsets emission, as I think was said in the opening remarks. And we find that the soil organic carbon was higher with bio inputs than it is with chemical inputs. However, the offset of emissions only lasts for as long or until the soil organic carbon reaches its equilibrium, and it then evens out later on. So again, this is one of the interesting or the important points to bear in mind when considering the economic and other co-benefits in the medium to long run. This was an overview of everything that is relevant on this topic from IFAD's portfolio, but I'll be very keen to hear more from the other participants and the other presenters about the agronomic and the context-specific issues that they are finding. Thanks very much, and back to you, Ning.
Okay, thank you very much, Clemens. And now allow me to introduce you to our next speaker from Maseno University, Peter Opala, who holds a PhD in soil science from Moi University. His research targets the development of economically attractive, environmentally sustainable, and socially acceptable soil fertility management technologies for smallholders farmers in developing countries. He has lectured in several universities and colleges in Kenya and is currently an associate professor in the Department of Crops and Soil Science at the Maseno University. Thank you, Peter. Now the floor is yours.
Thank you very much. And I'm honored again to be invited to be part of this conversation. I'll basically be dealing with the organic inputs and how they are managed on smallholder farmers in Kenya. Sorry for that. Edna, could you kindly assist me share? This one of mine is. Thank you. Thank you, Edna. So next slide, please. Next slide, please. So I'll give a brief overview of the history of organic input. It's not new. It has been used for decades. In fact, it's the main traditional way of managing fertility. So on our smallholder farms, we have various sources of nutrients, organic inputs being one of them. And the major ones will be crop residues. They are mainly used to provide nitrogen. And as we have heard from the previous presenter, nitrogen is one of the most limiting nutrients for crop production in Africa, the other being phosphorus. So without nitrogen, most of the crops perform very poorly. So proper management of these such organic inputs to ensure sustained productivity is of critical importance. Management of organic inputs in Africa has evolved over the years alongside other paradigms of soil fertility management. As we heard from the previous speakers, a lot of research is now going into this. In the 1960s, fertilizers became a bit cheaper, and we tried to borrow the green revolution model from South Asia. So fertilizers were used in the 60s. Next slide, please. Next, please. So, but because of increasing costs of fertilizer in the 1980s, there was renewed interest in the use of organic inputs to replenish soil fertility in Africa. Later, it was realized that these organic input management strategies were not giving as high yields as those of the mineral fertilizers. This later led to the paradigm of soil fertility management that advocated for integrated soil fertility management, whereby both organic and inorganic nutrient sources were used in combination. It was supposed to get advantages of both, or sort of to synergize. Intense research has therefore gone into this the view mainly is to try to achieve an understanding predictive on how we can use organic inputs just the way we use fertilizers. Because right now we can use fertilizers, we can recommend a particular rate for a particular soil, for a particular region, but for organic inputs, there's that variability. So we don't have those predictive management guidelines. Next please. So among the issues that have been of interest is the quality and quantity of available inputs on the farm. Because the main thing here is that most of the farms do not produce enough material that can sustain productivity on large areas. Unless you're doing small scale horticulture or high value crops on agronomic crops like maize, you may not generate enough organic materials to cover the whole farm. So that has been a challenge. Next slide, please. Next, please. So they have tried to characterize the quality of organic materials based on many parameters. Here, I'm only presenting for N, nitrogen and phosphorus, which are the main limiting. So I've subdivided them into the crop residues, animal manures, the compost, and then the green manures. So from that table, you can be able to see that most of the crop residues that we have on the farm have very low nitrogen, less than 1.5. According to the quality, those are low. Then animal manures are a bit high. We have domestic compost, quite low, but vermicompost, which is trying to be promoted, is quite high. The green manures are quite high, above 3%. And as we shall see later, that enables them to release nutrients. The challenge is the phosphorus. Phosphorus is quite low. And since phosphorus and nitrogen are actually limiting simultaneously in most of our soils, it becomes a challenge if you try to use only organic inputs to supply phosphorus, because you need to use quite large quantities, which are not sometimes available. So that sometimes a challenge, and that's why some people would want to use inorganic phosphorus from fertilizers, and then use organics to supply nitrogen. So that has been one of the issues. Next, please. Next. So I think I've already indicated that one of the main issues is low quantities, because they have competing uses. So you may have to use a lot, like for supply the normal requirements for maize, maybe 60 kilograms of nitrogen per hectare. You need over 10 tons of high quality green manure, and about the same for animal manures, which sometimes availability is a problem. If you try to use phosphorus for that, you may need to use 10 times that, maybe 20 tons, 30 tons of phosphorus, which may not be sustainable. The next slide, please. Next, please. So another issue that is of concern is the release of these nutrients from the organic material, because they're in organic form. So they must be released through decomposition and mineralization, because plants can only take in the inorganic forms. So predicting how much can be released and at what time is one of the things that also have occupied the minds of researchers. And they have tried to come up with some chemical indicators that can assist us predict what will mineralize or what will not, because sometimes if it's low in nitrogen and high in lignin and high in polyphenol content, it tends to immobilize or tie up the nitrogen, hence the crop suffers. But if it's of good quality, that means it has high nitrogen content and low in lignin, then it tends to release. The only challenge will be if it's very high quality and it releases too fast, then it may release when the crop does not need it. Hence, there may be waste or even a concern to the environment. But if it's again released too slowly, it becomes a challenge, because it will be released when the crop does not need it, and again, it will be a waste. Next slide, please. So researchers have tried to come up with a decision support system, which can be used to make recommendations on how to use organic materials of different qualities. So it can be used to predict whether they will be release the nutrients or tie them or immobilize. Next, please. So that is the decision tree, which tries just to guide. so that if a material is high in nitrogen, that's more than 2.5, and low in lignin and low in polyphenol on the left side, then you can directly apply it to supply nutrients. But if the nitrogen content is high, but the lignin and polyphenol are a bit high, then you may need to do integration so that the nitrogen from the fertilizer can assist in decomposition. But otherwise, if it's of low quality completely, high in lignin, low in nitrogen, then you may not need to use it as a fertilizer source. It may just be used as a mulch or to control other parameters in the soil other supplying nutrients. Next, please. Next. So I've talked about the synchronies, where you try to match the amount of nitrogen released with the crop demand. So the ideal situation would be to have a perfect synchrony whereby the nutrients is released when the crop needs it. But as I've said, if it's high quality, some of it may be released too fast, or if it's low quality, it may be released later. So sometimes we want to mix both low quality and high quality so that they release that in synchrony with the plant demand. But that's more of theoretical. It's very hard to achieve that. The other thing is that this decision support system does not apply to animal manures, which, although they are low in nitrogen in terms of compared to the organic materials, the green manures, they tend to release even at below 2.5. So again, that becomes a challenge. You not really come up with guidelines for management of organic manures, animal manures. Next, please. So because of those advantages and disadvantages of organic inputs, this paradigm of integrated soil fertility management has come in, because people realize you may not strictly go organic in some circumstances, especially I've said phosphorus is limiting. You may need to bring in some inorganic fertilizer. Otherwise, trying to rely on organic inputs alone in some of the areas, especially for agronomic crops, may be difficult, may be a challenge. Next slide, please. So I'll give an example here of experience from Western Kenya, where we did some experiment comparing a green manure, which was Tithonia, farmyard manure, and triple superphosphate and urea. This is inorganic combined. Then combined organic and inorganic, Tithonia and TSP, and then farmyard manure and TSP. So you have both soil manure, animal manure, soil, green manure, soil, inorganic, and the combinations. The control we applied no input. So what we could see here is that, and you had two sites, Kakamega is the blue and Bukura is orange. They are not very far from each other, maybe about 30 kilometers. So in one of the sites, the Bukura site, which is orange, there was a major problem of acidity. And acidity leads to aluminum toxicity, which limits crop growth. Kakamega didn't have that problem. So you can see the control is a bit good here and there. But to Tithonia, for both sites, it's almost equal, almost 4-point-something tons. Tithonia alone. Farmyard manure alone, Kakamega is a bit higher than Bukura. But when it came to inorganic, Kakamega is much higher than Bukura. Bukura, the inorganic did not respond at all. It's almost like the control because of aluminum toxicity. This side has aluminum toxicity. So that prevented the crop from taking up the inorganic fertilizer. But the organic materials from our study analysis, they were able to reduce aluminum levels in the soil. They were able to tie up aluminum, hence allowed the plant to take in the fertilizer. So you can see where you have combined with Tithonia or farmyard manure, the yields were they're much higher than where we have only inorganic. The other finding here interesting is that at both sites, the organics were almost similar. So they're able to be stable across environments. But for inorganic, you can see at one site, it's okay because there was no, let's say in Kakamega, it's a bit high because there was no aluminum toxicity. In the other site, it's quite low. So one of the importance of organic materials in some of these soils, like the Bukura one, is that they're able to reduce aluminum toxicity. Hence, they're able to almost to replace lime. We are recommending that where lime is expensive and is not available, then organic materials can be able to manage. Next slide, please. Next, please. So we proceeded and did some economic analysis. And what is emerging from this is that the cost of using organic materials was quite high. Tithonia had the highest yields, but when it comes to added costs, because we needed to use almost 10 tons of the green manure and the labor involved in harvesting, incorporating, transporting, it was quite high, so almost $6 or $5 per. And this is added cost. We use partial budgeting, so it's just what is above the control. So that made it the net benefits to be negative. The previous presenter talked about the economics, and it's just confirming that sometimes it can be negative because of some of these things. Farmyard manure, because it was locally sourced, the benefit was positive, but not that high. Urea and TSP, that was, this is in Kakamega, was profitable because at that site it was not acidic, etc. But now when it came to the other site, Bukura, where it was acidic, then the benefits were much higher because the organic was able to reduce acidity and hence yields were much higher. So the benefits were high for the green manure in Bukura. The TSP was negative, the inorganic TSP and urea, because there was no response, so the yields were quite low. But more importantly is the benefit cost ratio, which determines whether farmers will be able to take up this technology or not. So usually a value of 2 is assumed to be appropriate for adoption, but you can see from all these figures, it was low. It was only at one site at Bukura where farmyard manure gave benefit cost ratio of 4.49. That means it can be adopted by farmers in that area. So that was the only technology that proved beneficial. And it vindicates as most of the farmers are actually using farmyard manure. Next slide, please. So this is just an example of the Tithonia. We use the green manure. That's how it looks like. It's harvested on along the roadsides. Yeah, it's just a green manure. So the main findings, I think, I've already summarized, that organic sources of nutrients were superior to inorganic sources on acidic soils because of their ability to ameliorate aluminum toxicity. The response to organic inputs was more stable across sites than inorganic, but due to high labor costs, Tithonia was not profitable on maize, but could be more profitable maybe when you use it on high value crops like the horticultural crops. So we are recommending for such organics, we use them on horticultural crops, maybe high value than maize and such. Farmyard manure had the best benefit cost ratio and hence is the best for adoption. So in conclusion, from this presentation, tremendous progress has been made over the years towards understanding the biophysical aspects of organic input management. So we know quite a lot about the importance of organic matter and what does it to the soil. And in the process, many organic input technologies have been generated. However, our knowledge still remains imprecise. As I said, we don't have specific management guidelines that we can really rely on, particularly the socioeconomic perspective. Most of our studies, we have rarely been doing socioeconomics. Sometimes we just rely on yields to make recommendations, and as you have seen, that can be misleading. What is sometimes technically sound may not be economically feasible. Hence, adoption of organic matter technologies has been quite low in most of the farms. So the biggest challenge is actually to ensure that what we generate from research is adopted by the farmers, bridging the technology gap between technologies, generation, and actual uptake by the farmers. If you could do this, maybe we could improve on our food security. I was focusing mostly on the food security part of it. Thank you very much.
Okay, thank you very much, Peter, for sharing your insights. And now allow me to introduce you to our next speaker from the Research Institute of Organic Culture, Milka Kiboy. And she has vast experience working with smallholder farmers in Africa, Research Institute, agriculture and environment stakeholders, and higher learning institutions in developing and implementing soil health improvement and climate change mitigation strategies for improved food security and livelihood. She is an expert in organic farming, soil fertility, agroecology, farming practices, soil and water conservation, and climate change resilience strategies. She is currently the principal investigator of long-term farming systems trials project in Kenya that compared the performance of organic to conventional farming systems in terms of crop productivities, soil health, profitability, climate resilience, and sustainability. Additionally, she engages in partnering and fundraising for multidisciplinary, multi-countries development and capacity building projects. Milka, the floor is yours.
Thank you very much. And thank you for inviting me to this event. I hope you can see my screen.
Yes.
Okay. Yes. So today I'm going to talk about nitrogen budgets and flows in the African smallholder farming systems. And I am going to give two case examples where we have conducted research in Kenya under two projects. That is the organic resource management for soil fertility, and that is ORM for soil, and then the farming system comparison trials project that is also in Kenya and in other countries that I will show in the presentation. So as a way of introduction is just to emphasize what the my fellow presenters have said on declining soil fertility in Africa, which is mainly caused by the low soil nutrient in our soils here in Africa due to the limited use of soil inputs, be it the mineral fertilizers, be it the organic inputs, as well as nutrient mining, to mean that we are having to remove more nutrients from our soils and not replenishing our soils. And with the focus of our today's event is nitrogen, which is the most limiting nutrient for crop production in our smallholder farming systems in Africa. Good to note that the smallholder farming systems are the majority in Africa, and this is the nutrient that is mainly responsible for crop growth and yields, and especially the cereals, which is maize, and this is the main staple food for the population in Africa. Now, what are the challenges that we have in nitrogen balances at the farm levels in Africa? Good to note that nitrogen is the nutrient that is highly susceptible to denitrification. That is, we are losing it more than we are adding it through denitrification. Then there is through leaching, where the N is lost below the root zone for the crops. There is through the volatilization, then through runoff or erosion and overgrazing. And in addition, there is land degradation in Africa. Why? This is because of continuous monocropping in the limited land sizes that the smallholder farmers have in Africa. Africa is also very vulnerable to climate change. Specifically, we are talking of erratic rainfall, increased temperatures. This is responsible for mineralization of nutrients and more so nitrogen. In addition, there's continuous high population growth. That means that more population moving now into the marginal lands where the soils are already depleted, especially in terms of N, and the farmers are not adding in any nutrient even as they harvest the crops. Now, as we focus with the recent the Africa Fertilizer and Soil Health Summit, we still had the challenge of limited use of mineral fertilizer being presented in the smallholder farming systems in Africa. And mainly it's because of the accessibility due to infrastructure and the cost for these mineral fertilizers. And there's the suggestion that we triple the application of the mineral fertilizer by 2034 to 50 kilograms per hectare. But the question is, does this build up our N in the soil? Now, nitrogen use efficiency is predicted to be increased by at least 60% to support the profitable farming and environmental sustainability in Africa by 2034 if we use the 50 kilograms per hectare. Good to note that use of mineral fertilizer, we not likely to build up the cation exchange capacity, which is responsible for holding the nutrients. So ultimately, in terms of soil health in the summit, it was declared that there is need to promote organic agriculture practices so that we are able to improve soil health and mainly nitrogen. But how do we add in nitrogen, and how are we having nitrogen being removed from the agroecosystems? Now, for the inputs, we may add nitrogen by use of the organic inputs, which include different types of manures. Could be animal manure, it could be through compost. You could use the farmyard manure, and then there's the crop residue retention. We could also use it, add nitrogen by use of biomass transfer. Then there's the biological nitrogen fixation, whereby we have legume intercropping with cereals or any other crop. And there's also the inoculant application. Mineral fertilizer is also one of the ways to add nitrogen. However, we need to note that nitrogen from the mineral fertilizers is readily available and readily taken up by the crops, and that we are not able to build N in the soils. N is also injected in the soil through the atmospheric N. But we also have the outflows through the crops harvested. Crops take up nitrogen for growth and crop yields. So if the more you harvest yields, the more you're taking out also N. And unfortunately, there is continuous crop residue removal from the smallholder farming systems in Africa. And then there's also leaching below the root zone of the crops in the field. And this is mainly because we also don't build up the cation exchange capacity. Runoff and erosion is easily seen in the smallholder farming systems farms, because really we don't have the residues to hold in the water that is running on the land. There's also loss of N through the gaseous processes such as the volatilization and denitrification. And this is just a diagram that shows the inputs and the output of N in the farm levels in Africa. And more of it is also shown in one of the publications that is shown in the presentation. Now, what we have been encouraging the farmers so that we have improved N balance in the farms is instead of practicing continuous monocropping systems, then let's have intercropping system. And by intercropping does not necessarily mean that we have only the cereals and the legumes. There is also crop diversification, whereby you also integrate the vegetables. You could also include push-pull systems. For example, you could use the desmodium that helps in building the N in soils. Then there's the use of the cover crop and also crop rotation. In addition, we encourage the farmers to use high quality organic inputs instead of mainly using the synthetic, and which are not affordable to them, as well as the pesticides, the synthetic pesticides that easily have the residue in soils and also in the produce. So we encourage use of locally renewable resources that are available to the farmers, application of manure, compost, the tithonia that was presented lastly, and we also develop plant extracts for use as for pesticide management. Also, there is need to always continuously do training and knowledge sharing with farmers, whereby we encourage collective action and farmers work in groups, or we have cooperatives or associations where you continuously inform farmers of what is required, for example, in management of the organic inputs, in their preparation. And a very classical example is the preparation of animal manure. We have most of the farmers leaving the animal manure in the fields and not maybe covering the animal manure, hence limiting the quality of this animal manure. So just to show some case examples of the projects that we have run in Kenya, we have the Organic Resource Management for Soil project. This has been carried out in Zambia, in Mali, Ghana, and in Kenya. And here I show the mineral N response to various soil fertility resources, whereby we had a control. There was no input, and then a treatment on mineral fertilizer only, and then one with crop residue and mineral fertilizer, and then another with crop residue, mineral fertilizer, animal manure, and an intercropping treatment where we had crop residue, animal manure, and legume intercrop. And the legume here was the Dolichos lablab. And finally, we had one that had purely organic inputs, including the crop residue, Tithonia diversifolia, animal manure, and then crop residue, Tithonia diversifolia, and phosphate rock. From observation is that this was conducted for 2 seasons, that is the short rains, which is up here, and the long rains. For the short rain seasons, the study was conducted in central Kenya. The short rain season happens in October to December, while the long rains happens from March to June. Generally, the short rains, we have well-distributed rainfall in central Kenya. And also the long rains, we have erratic patterns. So with the short rains, you observe that the organic inputs had a better, mineral N had better response to the organic inputs as compared to the synthetic fertilizers. This is because the synthetic fertilizers are readily, the N is readily available for take up from the crop, for the crop, as compared when you have the organic inputs. For the other project that we have is the SysCom, and this is the Farming Systems Comparison Trials. For this one, we have been running the trial since 2007 up to date. And not only in Kenya, it's also in Bolivia, in India, and we had still an example of such in Malawi, which is still in Africa. So generally in SysCom, we compare the performance of conventional practices versus the pure organic agriculture practices. What you see here, there is something we call the conventional high, organic high, conventional low, and organic low. So for the high systems, we are mimicking smallholder farmers who will practice the agriculture for commercial purposes. While for the conventional low and the organic low, we mimic the farmers who are producing purely for consumption. But here we are able to go further and work on nitrogen balances, looking at the input versus the output. And as observed is in the organic high in 2 sites, also in central Kenya, we have a positive balance in terms of nitrogen retention as compared to where we have the lows. Meaning that we are taking out more N and not replenishing enough for the soils and also crop productivity. And just as observed, this is the same trend when it comes to crop production, whereby the organic high as well as the conventional high after all those years is that it has high crop productivity as compared to the organic lows and the conventional lows, whereby we are doing more of nutrient mining. Well, as I said, we still are running this project. It's in Kenya, Bolivia, and India. And we had a similar project in Malawi, in Africa. But then after doing all this, what are the lessons that we have learned to enable successful organic farming systems? One is on input preparation. There is need to always train the farmers on input preparation, especially the organic inputs. And for here, input preparation is where we see the difference in terms of costs, and mainly it's on labor management, which is observed to be higher when it comes to farmers who use organic inputs rather than the ones who use the synthetic fertilizer, because preparation is required. And the question is always for the smallholder farming systems. So what do we do? Do we mechanize the preparation to save on cost? Then the other thing that we have learned is input availability. It's always good to promote organic inputs that are available to the farmers. What is locally available to the farmer? If it's Tothonia, if it's Lantana, what is available is what is required to be promoted for easier uptake by the farmers. Then the application timing to ensure synchrony with the crop demand. Remember that when you apply the synthetic fertilizer, there's direct planting and there's readily uptake of N. But when it comes to the organic inputs, you need to apply it maybe days before the onset of the rains, because the organic inputs require moisture so as to mineralize. Thus, good management of organic inputs is necessary for build-up of N. The other lesson we learned is that there is a need to bolster knowledge and capacity building, especially for our farmers, so that they are able to learn on input preparation and also application. And finally, the other lesson that we have learned is on that for us to have soil and improvement, there is need for long-term research and there is need for long-term use of the organic inputs. Remember, when you build soil N, it means you build the soil organic matter, and thus high CAC, that is cation exchange capacity, that is going to hold the nutrients. And finally, what is my take-home message to you is that organic farming promotes lower nutrient losses and specifically N, hence the positive N budgets, but this means you have to practice good management of the organic inputs. Then intensive research on upscaling methods and accurate estimation of N flows is needed, because most of the times we do the plot level research. How about the landscape level research? And finally, there is need for smart policies where we need to do an integration of the policies so as to promote the uptake of the organic agriculture. So we could have integration of agricultural, environmental, and socio-economic policies so that to cater for the smallholder farming systems in our in Africa, where we have the smallholders being the main majority of the population practicing farming. Thank you very much for your attention, and that's my message to you.
Okay, thank you very much, Milka, for sharing your insights, especially highlight the take-home message. Our final presentation is from GIZ, Pro Soil, Soil Protection and Rehabilitation for Food Security, from David Custin. And David Custin manages GIZ Pro Soil project, which builds the capacity of smallhold farmers in Western Kenya on sustainable soil management and supports Kenya's Ministry of Agriculture and Livestock Development in providing a nationwide enabling environment for the same. He is a geographer by training and worked for GIZ in Addis Ababa and IFAD in Rome, Italy, before joining the ProSoil project. David, the floor is yours, please.
Yeah, thank you very much, and good afternoon from Western Kenya. It's my pleasure to contribute to this interesting event. My name is David Casting. I'm the project manager of a GIZ project, going by the name Soil Protection and Rehabilitation of Degraded Soils in Western Kenya. I will start by giving a bit of background on GIZ as an organization and who we are. GIZ is the German development agency, a federal enterprise owned by the government of Germany and active in about 120 countries worldwide. Our mandate is capacity building and training in collaboration with the partner governments of the government of Germany and share common objectives on a future worth living around the globe. Capacity building and the future worth living probably are very broad objectives. Specifically here, when talking about agriculture and nitrogen management, that speaks to food security first and foremost, but also to ensure other public benefit objectives such as ecosystem services and a healthy environment. Yeah, and this is basically the foundation of our work in Kenya and elsewhere around the globe. The project that I represent here is going by the name of Soil Protection and Rehabilitation for Food Security and the so-called Global Program. Global because the project or the program is implemented in several countries. You can see that here on the top right map. Basically, it summarizes 7 different projects that are implemented on the African continent and in India, all with the common objective to support sustainable soil management. But of course, as you can imagine, the climatic context, the soil, the socio-economic contexts in which these projects are working are different, and therefore some different approaches, techniques, and methodologies have to be applied. This is about a 10-11 years program with substantial funding from the government of Germany, as well as the European Union and the Bill and Melinda Gates Foundation. I have mentioned that different contexts require different solutions when it comes to soil health, but a basic principle that binds this global program together has been explained before by the other presenters, and that is the principle of integrated soil fertility management. In the global soil program, we look at healthy soils through a lens of 3 pillars. First and foremost, nutrients and nutrient availability. This is the macro and the micronutrients. And specifically here we find nitrogen as one of the key macronutrients that are being provided through different forms of mineral, but also organic sources. Speaking of organic sources, we look at the replenishment of biomass into the soil. This has multiple benefits in terms of pH regulation, carbon storage, the regulation of water holding capacity, and last but not least, also the facilitation of soil organisms, of soil life. Healthy soil is always also a living soil. I think the previous presenters have extensively talked about the relationship between mineral and organic sources and the role also of microbes and soil organisms therein. Yeah, I think here on the right-hand side, I have summarized a few key principles of integrated soil fertility management, and that this relationship between organic and inorganic sources basically enhances the resource efficiency of nutrient availability and of soil structure. I believe that purely organic farming, as in biomass-based soil amendments only, can work, but it primarily works under favorable market conditions, which allow farmers to be rewarded for this specific effort in really banking on biomass inputs. Yeah, I've been asked to talk specifically about good practices and experiences from capacity building and awareness creation around biological nitrogen fixation and nitrogen management in smallholder farming systems. I want to do this through a specific example of Mucuna pruriens. Mucuna pruriens, known as the velvet bean, is one of many green manure cover crops that the ProSoil project is promoting in Western Kenya, but also elsewhere on the continent. Mucuna has multiple benefits. It can replenish up to 300 kilograms of nitrogen per hectare per season into soils under favorable conditions, and therefore has at least a partial potential to substitute for mineral fertilizer. It produces ample amounts of biomass, which, as explained previously, is crucial for healthy soils. And also, it covers the ground all year round, as you can see here on the top right picture, when intercropped with maize, for example, or when used as a rotational crop with maize or with horticultural crops, you have an all year round ground coverage that protects against soil erosion. And then, especially in tropical climates with high rainfall intensities, this, I think, is a crucial factor to consider. The experience of now 8-9 years of implementing the Global Soil Program shows, however, then that the adoption by farmers is especially promising when looking at green manure cover crops in general, that you have a secondary purpose beyond soil health enhancement. And that means if you plant a cover crop, a green manure that is enhancing soil health, there should be, in an ideal situation, other benefits that the farmer can make use of from this particular green manure. This could be, for example, a livestock feed, or this could be also for human consumption. It could be for firewood, etc. We learned that nitrogen fixation alone is often insufficient to integrate such green manure cover crops into farming systems alone. For the specific case of Mucuna, there are two major limitations to that. First of all, for human consumption, the processing requirements of Mucuna pruriens are quite high, and the demand in the market is also quite limited. Mucuna is, to a certain extent, a popular food supplement because it has health benefits if processed adequately to a certain procedure. But as in every food supplement market, the demand is limited. A supplement cannot replace, for example, beans or any other staple crop. The project I'm representing here is currently exploring other ways of making use of Mucuna as a feed, but also that is the green leafy material, but also the pods. And for example, as a livestock or fish feed or for medical purposes, each of these different purposes has their own specific barriers, such as cost, demand, certification, etc. Overcoming those would really contribute to the adoption of Mucuna by farmers at scale. Good practices in promoting biological nitrogen fixation takes basically the Mucuna experience to a higher level. I think thinking beyond a nitrogen fixation from the start is crucial for any project intervention to succeed. Farmers may not see nitrogen fixation, nutrient replenishment, and soil health as their most immediate need. And this is crucial to understand when building the capacity and the awareness of farmers around soil health considerations, really to understand what are the perceived immediate needs of farmers. They might go beyond, way beyond the agricultural sector alone, may touch upon issues of education, health concerns, and may beyond the respective project objectives. We have also learned that transforming a farming system in a way that also previous presenter has described requires changing behavior and continuous consultation and a mutual learning process between agricultural trainers and farmers. And we are looking here at a minimum of 3 years to make a significant change. Unfortunately, a lot of project interventions do not have that amount of time. On the right-hand side, you see two situations of agricultural extension and training. And if you look closely, you will notice that the audience here is different. Being conscious that different audiences require different ways of communication. And here I'm talking about differences in age and gender, and also in the position. Talking to a well-endowed farmer or a subsistence farmer, a commercial farmer, or a policymaker makes a great difference in succeeding in creating change and getting the message across. And understanding the economic realities of different farmers that we might be dealing with in the field is also crucial in that. Again, a subsistence farmer may have quite different objectives and needs than a commercial farmer. One size fits all communication approach will usually not lead to satisfying adoption rates of new technologies. Maybe one general conclusion we can draw from our work in the field is emphasizing the resource efficiency rather than the fertilizer substitution is usually a promising way to, as a rule of thumb, in communicating with farmers as well as with policymakers, with trainer extension officers, and eventually it's not an either-or perspective between organic, inorganic, but enhancing resource efficiency is an economic reality and eventually a must for conventional as well as organic farmers alike. Looking at the scarce resources that we have, mineral fertilizers as well as biomass, as previous presenters have highlighted. Lastly, I want to conclude with some recommendations from our experience of implementing the Global Soil Program. Agricultural extension services, training and capacity building, and constant consultation and mentoring, but also learning from farmers is key in achieving high adoption rates, a change of farming systems, and eventually the agricultural sector as a whole. However, we observe that governments around the globe are hesitant or have abundant investments into agricultural extension services. And I believe this is a critical factor to correct if we want to move, especially for low-income farmers, to move from a capital-intensive way of farming to a rather knowledge-intensive way. Agricultural training and extension services, and this investment is really key to success. Governments should also consider incentivizing good agricultural practices, such as green manure, cover crops, and others, through rules, regulations, but also through subsidies. The current reality of agricultural subsidy programs is that they favor agricultural inputs such as fertilizers. And again, this is not an either-or question, but probably one where smart subsidy programs would reward good agricultural practices that also protect public goods by providing additional inputs and maybe also monetary incentives. I have highlighted the importance to think beyond the nitrogen cycle or the immediate production system as such. I think here also the private sector has a key role in making use of business opportunities that present themselves and incentivizing, for example, the adoption of innovative technologies that lead to nitrogen cycling off the farm, in processing such cover crops into livestock feed, etc. And last but not least, and alluding to the title of today's event, where economically feasible, create an enabling environment for organic farming, not only on the African continent, but worldwide. With that, I conclude my presentation here and thank you for your attention.
Thank you very much, David. And we have come to the end of our presentations. I would like to thank all our panelists for their contributions. Now I hand over to my colleague, James Lomas, to moderate the Q&A session. James,
Thank you.
please.
Thanks so much, Ning, and it's great to see you all. I'm wondering if the four presenters could put their cameras on so we could all see them. Look, I think it was very, very interesting to hear about the four examples. I came away with sort of 2 or 3 takeaways from this. The first one being that any kind of organic or soil health focused work is really not a quick fix, and I think that's really clear, and it's something that at UNEP we're very conscious about, and something that work that we're doing on this really understands that there is a period of transition, transformation, etc. Soil health is important and it increases resilience, but it's labor intensive. I think this is really important. I think this comes out really, really clearly. And that messaging is key. And I think being clear about who you're talking to when it comes to policy, through to private sector, through to farming, I think is really important too. Now, I understood that we would put our cameras on, but I don't see that. Maybe it's the connection we have in Nairobi, but that doesn't matter. Maybe we can just carry on. I don't see any cameras on at all. But let's push on because we have 10 minutes. So why don't we go first of all to Clémence, who was our first speaker. And I think what would be interesting to hear from just to hear from her is that we had a question in from a participant who said that person is interested to know what was the ratio of economic benefits gained by small farmers versus bigger farmers, and what really was the difference. What were the factors that played the role in the difference of economic benefits between the two? I wonder if you have that the data, or maybe you can express any answers that you might have specifically on large versus small. Thank you.
Yeah, thanks, James. Hopefully you can see me. My camera is on, so I don't know if it's a connectivity issues, but I can also see some of the other presenters. Yeah.
Okay.
So unfortunately, I don't have the data because IFAD focuses on smallholder farmers. What I will say from experience is that the incentives are different and the means of the larger farmers versus the smallholders farmers are very different. So across all of the presenters, we've seen that the costs for organic inputs are high, and unless they are produced on the farm through some manure and compost practices, buying them on the markets if and where they are available can be quite high. And this increases in costs might not be affordable by some of the farmers, and that's why it's really important that they be accompanied in the transition. In comparison, some of the larger, more commercial farmers might have more savings and profit margins to be able to access some of these costs and to be able to perhaps also be more in tune with some of the consumers' demand for more healthy products and more, as a result, organic products, so that they're able to then tap into those markets where they can get a higher price for their products and then tap into their savings or extra profit in order to buy the inputs that are necessary. So this is just a bit of a hunch from different experiences and observations. But again, IFAD only works with smallholder farmers, so I'm not able to give any more specific data. Perhaps colleagues in their respective case studies will have some more to share.
Thank you so much, Clémence. I think you made good points. Something that I did before I joined UNEP was that I was in charge of a large commercial growing operation where the market dictated that we should have a percentage of our hectarage as organic. Unfortunately, though, the where we were growing, it simply wasn't physiologically correct to be growing things organically. So in the end, that became quite a burden on the operation itself. So I think when it comes to organics as opposed to good practices for soil health, or as David said, integrated soil fertility management, I think we've got to see that there is a difference between going down the organic route per se and then really sort of thinking as a continuum of like, right, okay, so if conventional or unsustainable input focused farming is on this side, organic farming is maybe where we want to get to in an ideal world. That middle part is kind of where the sweet spot, mostly where we want to get to when it comes to food and agriculture, where we do increase our resilience, we do invest in our soil health, but we also have the opportunity to utilize inputs where needed. David, I think you just came on camera there. I'm wondering if you could elaborate slightly and just very quickly, because then I want to get to Peter and to Milka as well. Maybe you can elaborate maybe on some of the policy implications that your work has put forward. For example, how can governments really support this soil-centric approach?
Yeah, thank you, James. The project I'm heading here in Kenya has supported the Ministry of Agriculture to develop the Agricultural Soil Management Policy 2023. This provides a comprehensive framework for government action on soil health and a good national foundation to implement the action plan of the African Union's Fertilizer and Soil Health Summit. The development of the policy document was a 5-year, 6-year process. Such development procedures take time, and yet a document is a declaration of interest, I would think. Policy action, I think, requires a restructuring of subsidy schemes, of the adoption of new rules and regulations, and eventually also the enactment of the same. And I think that's where the interesting part of the work begins. The project I am heading is still active for the next 2 years here in Kenya. We're looking forward to support the government of Kenya in the same. My guess would be that such policy changes are easier to be observed on the local level. That is, with local governments which are closer to farmers than on the at national level. But we're going to pursue both. And I think, well, you have to start from somewhere. Having a policy framework, I think, is the first of many steps. I think key would be to really speed up the development process of such things, because in achieving the SDGs, we're running out of time.
Okay, thank you. Let me, thanks so much. Let me say, yes, haha. So you've hit on something that's really important, is that soil health is going to be time intensive. It's going to be labor intensive. It's going to take time. There's got to be patience. There's got to be best practices. Soil organic matter has to be built up over years. But yet we do have this crisis. We do have the SDGs coming up. So I think there is a tension there. Can I go quickly to Milka? And Milka, I'd quite like to drop you the $1 million question. And this is something from somebody that wrote in a question, and this is around Sri Lanka, and their idea that they would go quickly transition to an to a purely organic system. and the data showed that because it was, I think, done quite quickly, that yields, this is from our a participant, is quoting that crop yield dropped by 20 to 40% in 1 year. Maybe you can have any comments about that, and maybe give us some cautionary tales that you might be able to provide when it comes to a transition to more sustainable farming. Over.
Thank you, James, for that. Yeah, I think one thing that we need to all agree on is that organic systems don't work within the shortest time possible. This is because it takes time, and this is because of the practices that we are promoting, especially the use of the organic inputs. And also one of the other thing is the mulching and all that. One thing that we have a drop in crop productivity when you just transition to organic agriculture is because, one, there's need to know the quality of the organic input that you're using. What is the lignin, the polyphenol content, so that you allow mineralization of these nutrients that the crops demand. Secondly is the application timing or the incorporation of these inputs into the soil. If the release of the nutrients or the N, the P, the K from the input does not correspond with the crop demand, then you can be sure that the productivity has to go down. But if you have a synchronization of crop demand and the release from the soils, then there is an increase in crop production. Thirdly is that there is need to build soil organic matter first. And this I'm very specific with the soils in Africa. First it is to accept that the soils are degraded. So you have to first build the soils, the soil organic matter. That means that we raise the pH where we have acidic soils, and raise the CEC, that is the cation exchange capacity. That way we are able to hold the nutrients, and then they are available to the crops. But if you're just applying the mineral fertilizer and then we just planting maize and it's taken up every other time, then there's continuous degrading of the soils. So what happens to the sustainability aspect? In the future, are we able to still use these soils for that high production with the mineral fertilizers? It's simply a no. So that's why we need to look at the inputs preparation, the application timing, what is available, locally available to the farmers, because different types of organic inputs, different areas. Tithonia may be in Western Kenya, it may not be in Northern Kenya. Lantana may be in Central Kenya, but not in other parts of Africa. So it's about what is available, and then how are we managing it? How are we training the farmers so that they are able to take up these practices? So yes, I agree the shortest time for Sri Lanka would not really have worked, but it takes time. But with the right practices, then you're able to close the yield gap for the different crops. Thank you.
Sorry, my microphone was on mute. Thanks so much, Milka. I'm inclined to very much agree with what you said. It's all about the planning, etc. But let me just give the final word to Peter. We have many questions which hopefully we can sort of distribute out to you. They're quite technical ones, and we haven't got time for that. So Peter, why don't I give you the word for a minute to give your reflections, and then I'll give the floor back to Ning to close. So Peter, over to you.
Thank you very much, James. I think from what you have heard today, there's some consistency. What we need to do is, what people don't appreciate is that the use of organics is quite knowledge intensive. Unlike the use of inorganics, it requires a lot of understanding to manage inorganics, which can be quite complicated among the farmers, smallholder farmers. They may not understand these sciences of mineralization, immobilization, synchrony, rates. As I said, it's not as predictable as inorganics. And that's a major challenge also to the extension workers. Majority of them don't understand these technicalities. So they may not know when to integrate with fertilizer, when to apply nitrogen alone, when to apply phosphorus at what rate. So in most cases, you'll find them making a recommendation, blanket recommendation that use 5 tons of tithone or use 5 tons of let's say, farmyard manure. And once farmers realize the variability, this season they are getting it, next season they're not getting it. One of the presenters had said, manures sometimes are very variable. So depending on how they are managed, one season they could be high quality, low quality. So farmers get disappointed. Maybe this season it was okay, the next season it was okay. So with these variabilities in responses to these materials, it becomes very hard to predict what might happen in the next season. Hence, as I said, adoption has been relatively low. Like when we have now these subsidies, fertilizers, farmers have rushed to them because they're able to see a response within a very short time. And as has been said, organics take time. Some may not appreciate the importance, like these things of cation exchange capacity that was being talked about, improved soil quality, cation exchange capacity, building the organic carbon, which is very important for sustainability. Farmers don't have time for that. They want immediate response.
Exactly.
So probably we should train people to appreciate that apart from the short-term gains, without the organic materials, again, the quality of the soil depreciate and eventually we may not be able to produce. Thank you so much.
Thanks so much, Peter. And that reminds me a little bit about the situation we had. It's calmed down a bit now, but in 2022, where we had such a high increase in fertilizer prices. And that in itself was an incentive to think differently about how we manage our soils. Thank you so much. I'm sorry that we could only answer a few questions, but I'm sure Wanjiru will do her best to make sure that all of them are answered at some point by the panelists. Thank you so much. Let me give the word back to Nick. Thanks.
Okay, thank you very much, James, for moderating this very interesting Q&A session. We are not able to answer all questions, but we will make sure to address this and reflect the discussions in the summary brief that we will share along with the recording of the webinar. Thank you, Clemens, Mika, Peter, David, so much for sharing your insights with the participants. Also, I would like to thank the participants very much for your interest and participation in this webinar. And now we close this webinar, and we look forward to working with you closely to address the sustainable issue. Okay, bye-bye.
Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.